So in this video, we are going to look at the solutions to the try exercises for the different levels that we put up after the lesson 5 of Basic Algebra in full. So we are starting with the first one, 3x squared times 2x raised to power 4. Just like we did in the main lesson, we are going to group the numbers and then group the letters so that we can apply the laws to the letters. So that gives us 3 times 2 for the numbers, then for the letters, which is only x anyway, x raised to power 2 times x raised to power 4. If we simplify this further, it gives us 6, that's 3 times 2, 6. Then for the x, based on the law of multiplication with the same base, this is the same base, this is the same base, and they're multiplying themselves. So this gives us x raised to power 2 plus 4. So when we simplify further, it gives us 6x raised to power 6, and that's the answer for the first try exercise. Now for the second try exercise, as you can see, 2a raised to power 3b all raised to power 2. That power of 2 belongs to everything in that bracket based on the law of power of a product as we learned in the main lesson. So we are going to apply that power of 2 to all the items in that bracket. So that will give us 2 to the power of 2, a to the power of 3, all to the power of 2, b to the power of 2. Now 2 to the power of 2 is 4. A to the power of 3 to the power of 2 is another law, which is power of a power. In this case, it means that we should multiply the 3 and the 2. So this gives us a raised to power 3 times 2 and then b raised to power 2. Simplifying further gives us 4a raised to the power of 6b squared, and that will be the final answer. For this third try exercise, we are going to first of all assign the division sign to all the items in that bracket like we did in the main lesson. So this gives us 12x raised to power 5 y raised to power minus 2 divided by 4 divided by x to the power of minus 1 divided by y to the power of 3. Now, the more you solve this, the more you get used to it. You may not need to start writing them out like this one by one, but I'm just doing it so that people don't get confused. Okay, so at this point, we are now going to collect like terms in the multiplication family way as we always do. So we'll pull all the numbers to the left, then followed by x, then followed by y. So that gives us 12 divided by 4. And remember, since the series started, we've always been saying that every number must move with its operator, and its operator is the operator to the left of it, not the one to the right of it. Okay, so 4 will move with this divided by, and that was the reason why we separated the divided by at the beginning before we started. So that gives us 12 divided by 4. Then for the x, we have x raised to power 5 divided by x raised to power minus 1, which is this and this we've taken. Then the y is left, y raised to the power of minus 2 divided by y raised to the power of 3, which is this and this we've taken. Alright, so to simplify further now and apply the laws where we can, 12 divided by 4, we know it is 3. X raised to the power of 5 divided by x raised to the power of minus 1. Based on the law of division with the same base, they have the same base and they are dividing themselves. It gives us x raised to power 5 minus 1, and then y raised to power minus 2 minus 3. The division sign makes it minus, the 3 is there and the minus 2 is there. So this gives us 3x to the power of 5 minus 1 is 5 plus 1, because minus times minus is plus. So this gives us, if you don't know how to do multiplication and addition of negative numbers, go and watch our previous lessons. We covered it in great detail there. So that gives us 3x raised to power 5 plus 1, which is 6, and then y raised to power minus 2 minus 3 is minus 5. So y raised to power minus 5. The question says it wants only positive indices. So we need to pull this y raised to power minus 5 downwards so that it will become y raised to power 5 based on the law of negative exponents. So this gives us 3x to the power of 6 over y to the power of 5. And this now becomes the final answer. So for the final and most advanced try exercise, we are going to rewrite it so that we have a proper orientation, numerator and denominator. So this is it. The next thing we are doing, we are looking at the expression. Are all the operators from the same family? Yes, they are. They are all from the multiplication family. And because of that, we have the right to split the terms and move them around as well for the convenience of solving. But remember that the roots, the inside of the root is sacred. So we can only combine two roots. And in this case, we are going to combine these two roots because they meet the qualification, the criteria for combining, just like we discussed in the main lesson. So applying some of the laws, starting from the left, these two here belongs to everything in this bracket based on the law of power of a product. In the same way, these three here belongs to everything in this bracket. Same law, power of a product. So we are going to assign it to them that way. So that will give us 3 to the power of 2, a to the power of minus 2 times 2, which is minus 4, b to the power of 3 times 2, which is 6, over 2 to the power of 3, a to the power of 3, b to the power of minus 1 times 3, which is minus 3, then multiplied by, so now for this side, we are going to combine the two roots because they meet those two criteria we discussed in the main lesson for combining roots, which is that they are both roots themselves, and secondly, they are in the setting of a multiplication family. There is no addition or subtraction involved here. So based on that, we are going to combine them, maintaining their position 20 a raised to power 5 b squared over 5a squared b to the power of 4. Now, let us try to see if we can solve anything more inside the roots. 5 into 5, 1. 5 into 24. Simplifying this further now gives us 3 to the power of 2 is 9, a to the power of minus 4, b to the power of 6, over 2 to the power of 3 is 8, a to the power of 3, b to the power of minus 3, multiplied by, now we have 4 in this root, and we know that root 4 is 2, so we quickly move the 4 out and it becomes 2. So that gives us 2 roots. Then let us now apply the laws here. A raised to power 5 is dividing a raised to power 2, which is a to the power of 5 minus 2. Then b to the power of 2 is dividing b to the power of 4, which is b to the power of 2 minus 4. If we do the same thing here on this side, we have 9 over 8, a to the power of minus 4 minus 3, b to the power of 6 minus 3. Then on this side we simplify further. This gives us 2 roots. A to the power of 5 minus 2 gives us a to the power of 3. Then b to the power of 2 minus 4 is b to the power of minus 2. So if we now simplify this, it gives us 9 over 8. A to the power of minus 4 minus 3 is minus 7. B to the power of 6 minus 3 is 6 plus 3, which is 9. So b to the power of 9 times 2 roots a to the power of 3 over b to the power of 2. What we simply did here is to move this b to the power of minus 2 below so that we can get rid of the negative exponents. This is based on the law of negative exponents. And now that we've done this b squared, since it is inside this root and it is squared, the squared can cancel the square root portion for the b, and so the b can come out of the root as well. So this gives us 9 a to the power of minus 7 b to the power of 9 over 8 times 2 over b, because this b is still the denominator, don't forget, roots a to the power of 3. Now we still have numbers scattered. 2 is here, 9 is here, 8 is here. So let's group them again, collecting like terms in the multiplication family way. So this gives us 9 times 2 over 8. That's if we bring these two closer to 9. Then we want to group the a now. A to the power of minus 7, root a raised to power 3 cannot join it because remember, the inner part of the root is sacred. Then we have times b to the power of 9 divided by b, which is this b here, is this b here. This b to the power of 9 is this b here, b to the power of 9 here. Then we still have our roots, a to the power of 3. Simplifying further gives us, if 2 cancels 2, it gives us 1. 2 cancels 8, gives us 4. We also want to move this a to the power of minus 7 below, since the question wants us to keep only positive indices. So to do that, we just have to move the a to the power of minus 7 below. So that will now give us 9 over 4 times 1 over a to the power of 7 times b to the power of 9 minus 1, that is this one here, then root a to the power of 3. Now remember, we are supposed to simplify this thing to the simplest form. So if we look at these roots here, this is a to the power of 3. Based on this prime factorization we discussed in the last lesson, although we don't know the exact number a would be, but we know that there are 3 copies of a in this root. So what do? We know that if we have a squared, the squared can cancel the roots. But this is not a squared, this is a to the power of 3. So the best thing we can do is to split this a to the power of 3 to a squared and a, so that the a squared can at least leave the root and leave just a. So that's exactly what we will do. 9 over 4 times 1 over a to the power of 7 times b to the power of 9 minus 1, which is 8. Then root a squared times a, in which case this a squared can now leave the roots and become a. Or if we want to do it like we did it in the main lesson, we can say a times a times a. And then if we look at it in pairs, 2 a's are here. So for 2 of them to go, 1 will be sacrificed and then 1 will come out. So this now finally gives us 9 over 4 times 1 over a to the power of 7 times b to the power of 8 times a root a. That is, one of these a's made it out, the other one has been sacrificed for the square roots, and then the other a is what is here. So if we now combine like terms again in the multiplication family way, it gives us 9 over 4 times a divided by a to the power of 7. That is, I took this a here and I'm dividing it by this a to the power of 7. Then times b to the power of 8 root a. That is just this and this. So finally that gives us 9 over 4 times a to the power of 1 minus 7 based on division with the same base times b to the power of 8 root a, which is equal to 9. A to the power of 1 minus 7 is minus 6. So 9a to the power of minus 6 b to the power of 8 root a over 4. And because we don't want negative indices, this a to the power of minus 6 has to come down. So that will now give us 9b to the power of 8 root a over 4a to the power of 6. And this now becomes the final answer. It's not difficult. It's all about trying to figure out what to do to get the final answer. And like I said in the last lesson, you don't want roots in your answer. So when you are solving this kind of question, what is on your mind is, how do I get rid of the roots as much as possible? So that's us for all the try exercises. There are so many more exercises on our website, mathinfo.com. So visit it, choose your level, and keep on solving. And as you do, remember, in mathematics, it's all connected.